Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0135 indicates a malfunction in the air-fuel AF sensor's heater circuit, specifically sensor 1. This DTC is crucial as the AF sensor is responsible for monitoring the air-fuel mixture in the engine, providing vital data to the powertrain control module (PCM) to optimize fuel efficiency and reduce emissions, located in the exhaust manifold or exhaust pipe before the catalytic converter. Sensor 1 plays a key role in emissions control. A malfunction can significantly affect engine performance, fuel economy, and increase emissions. Thus, it's critical to address the issue promptly. The code identifies that there's a potential heater circuit issue, which can prevent the sensor from reaching the proper operating temperature quickly, affecting its ability to provide accurate readings. Engaging in troubleshooting for this DTC ensures that the vehicle remains compliant with emission standards while performing optimally. The A filter sensor, also known as the O2 sensor, plays a pivotal role in monitoring the air-fuel ratio, which is essential for optimal engine performance. In the Honda Fit, sensor 1 is located upstream of the catalytic converter, usually welded into the exhaust manifold or exhaust pipe. This sensor generates a voltage based on the amount of oxygen present in the exhaust gases compared to the ambient air. Its primary function is to provide feedback to the PCM to adjust fuel injection and ignition timing, ensuring efficient combustion. A malfunction in this sensor's heater circuit can lead to inaccurate readings, further straining the engine's efficiency and possibly causing the engine to enter a default operating mode. This highlights the importance of checking the heater circuit whenever DTC P0135 is present to maintain optimal vehicle performance. Several potential causes could lead to the P0135 error code. Firstly, a malfunctioning heater in the AF sensor itself can prevent it from reaching optimal operating temperature, triggering the DTC. Wiring issues, including damaged or corroded wires in the AF sensor's heater circuit, can cause interruptions in the flow of electrical current. Moreover, poor connections at the PCM or the AF sensor connectors can lead to erratic performance, which might incorrectly trigger this DTC. Additionally, fuse failures can disrupt the power supply to the heater circuit, further complicating the issue. Identifying the specific cause is crucial, as addressing these issues will help clear the DTC and restore proper sensor functionality. When DTC P0135 is triggered, several noticeable symptoms may manifest. The most immediate indication is typically the activation of the check engine light, alerting the driver that there's an issue that needs attention. Additionally, drivers may experience a noticeable drop in fuel economy as the engine struggles to maintain an efficient air-fuel mixture without accurate data from the A fuel sensor. Rough engine performance, including hesitation during acceleration and unstable idle, can also be symptoms stemming from this DTC. If the vehicle enters limp mode, performance can significantly decline, affecting drivability. Being aware of these symptoms can help in timely diagnosis and repair, preventing further complications. The first troubleshooting step for DTC P0135 involves verifying the problem through the Honda Diagnostic System, HDS. To commence, turn the vehicle to the on mode, which powers the electrical systems without starting the engine. It's important to clear any stored trouble codes using the HDS, as this allows for accurate monitoring of the vehicle's current state without previous codes interfering with diagnostic efforts. Once cleared, start the engine and observe the HDS for any pending or confirmed trouble codes that may appear. If the P0135 code is presented, it indicates a recurring issue with the AF sensor's heater circuit. However, if it's not indicated, this may suggest an intermittent failure, leading to further investigation into potential poor connections and related components. In the second step of the troubleshooting process, the technician needs to check for any pending or confirmed DTCs using the HDS again. This step ensures that there are no additional codes that could indicate related issues, specifically checking for codes like P1658 or P1659, which can signify problems within the Electronic Throttle Control System, ETCS. If either of these codes is indicated, it's essential to follow their specific troubleshooting procedures. However, if no such DTCs appear, then the technician should proceed to the next step in the process, focusing on ensuring the AF sensor itself is functioning properly. This methodical approach can help narrow down the troubleshooting efforts efficiently. The third troubleshooting step involves a critical fuse check to ensure that the flow of electricity to the AF sensor's heater circuit is uninterrupted. Start by turning the vehicle to the off mode to ensure safety. Locate and then check fuse number B30, which is a 10-amp fuse found in the underhood fuse relay box. It's important to confirm that this fuse is intact. If the fuse is blown, it may signify an electrical fault within the system. If the fuse is functional, the troubleshooting continues to the next steps, as a working fuse indicates that the circuit is receiving power, allowing further tests on the AF sensor and its connections. Step 4 of the troubleshooting guide requires disconnecting the AF sensor, sensor 1, from its connector. The objective here is to measure the internal heater resistance of the sensor using a multimeter, specifically between test points 1 and 2, while the vehicle is in the off mode. The expected resistance reading should be between 2.0 and 2.7 ohms at room temperature. If the readings fall within this range, it confirms the internal heater circuit of the sensor is functional. If the reading deviates from this specification, this points to a malfunctioning AF sensor, necessitating its replacement to ensure proper engine operation and compliance with emission standards. During Step 5, the focus shifts to checking the internal circuit continuity of the AF sensor, sensor 1. After disconnecting the 4P connector, use the multimeter to inspect the continuity between terminal points of the sensor and the 4P connector. This is crucial because it verifies whether the sensor can transmit data effectively to the PCM. The vehicle should still be in the off mode during this test. If continuity exists from the terminals to the AF sensor's input pins, the sensor is functioning correctly. However, if continuity is not detected, it suggests the necessity of replacing the AF sensor due to potential internal damage or circuit failure. In the 6th troubleshooting step, you will perform a shorted wire check on the AF sensor heater circuit. This involves jumping the SCS line using the HDS for diagnostic purposes. Next, disconnect the PCM connector C, which connects to the engine's PCM, and check for continuity between specific test points. These points include the point at PCM connector C and body ground, while the vehicle is in the off mode. If continuity is detected, this indicates that there is a short in the AFHT wire between the PCM and the AF sensor. Repairing this short is crucial to restoring the integrity of the circuit and ensuring proper functionality of the AF sensor heater circuit. 7th in the series of troubleshooting steps is the open wire check for the AFHT line. This test will also be performed with the vehicle in the off mode and involves checking for continuity between the AF sensor 4P connector number 4 and PCM connector C number 7. If continuity is confirmed, it indicates that the wire is intact, allowing proper communication between the AF sensor and the PCM. If there is no continuity, This suggests an open or broken wire that could be causing the circuit malfunction. Identifying and repairing this broken wire is essential for restoring the functionality of the AF sensor's heater circuit. In Step 8, the troubleshooting continues with testing the IGPS LAF line for clear indications of proper voltage flow. This requires turning the vehicle to the on mode and measuring the voltage from the AF sensor, sensor 1, 4P connector number 3, to a body ground point. Ideally, the reading should show battery voltage. If the voltage is present, it confirms that the IGPS line is functioning properly. However, if there's no battery voltage, it suggests an open wire situation between the AF sensor and the number B30 fuse in the underhood fuse/relay box. This open wire needs to be located and repaired to restore full functionality and ensure the vehicle's emission system operates efficiently. The final troubleshooting step requires a thorough check of the IGPS LAF line, beginning with the removal of the number B30 10A fuse from the underhood fuse relay box. Check for continuity from the A sensor, sensor 1, 4P connector number 3, to body ground, while ensuring the vehicle is in the off mode and the fuse is removed. If continuity is present, this indicates there's a short in the IGPS wire that needs repair between the A sensor and the B30 fuse. If continuity isn't detected, it verifies that the IGPS wire is intact, leading to the necessity of replacing the number B30 fuse and possibly parts of the fuse relay box if other fuses also blow. After completing all the troubleshooting steps and any necessary repairs relating to DTC P0135, it is crucial to perform a final verification of all repairs. This involves confirming that all components associated with the AF sensor heater circuit have been addressed, ensuring all connections are secure and wiring is intact. Next, recheck the DTC status using the HDS to ensure that the P0135 code has been cleared and does not reappear. Finally, a test drive of the vehicle should be conducted to ensure that it operates smoothly without any performance issues or warning lights. This test is vital to confirm that the repairs were successful and that the vehicle is functioning correctly. Preventive maintenance plays a significant role in ensuring long-term vehicle health, especially concerning systems monitored by sensors. Regularly inspecting the AF sensors and related wiring connections can help identify wear and tear before issues arise. Ensuring that the electrical connections are clean and free of corrosion can prevent many problems associated with DTCs related to sensor malfunctions. Moreover, keeping the PCM software updated is vital, as manufacturers release updates to resolve known issues and improve performance. Adopting these preventive measures not only enhances vehicle reliability, but also contributes to better fuel efficiency and lower emissions. In conclusion, understanding and troubleshooting DTC P0135 related to the AF sensor heater circuit malfunction is essential for maintaining optimal vehicle performance in the Honda Fit. Key troubleshooting steps include verifying the problem, checking for DTCs, inspecting fuses, checking the AF sensor's internal components for functionality, and ensuring wire integrity throughout the circuit. Addressing potential causes like faulty sensors, wiring, or poor connections is vital to ensure the engine operates smoothly. Finally, performing regular preventive checks on electrical systems and keeping the software updated can go a long way in preventing this and similar DTC codes from occurring in the future. Please like and subscribe to the channel. See you next time.